All right, guys. Measurement of central tendencies is complete. So we look mean, median, mode, population mean, sample mean, all that fun stuff. And then we are on to distributions. Normal distribution we went over here just looks like that. Bell curve, skewed left, pulled to the left, skewed right, pulled to the right, also negatively skewed and positively skewed. And bimodal, and let's keep going on to weighted mean. I don't know if I got to that. So with weighted mean, what you want to do here is take each weight. So 4 times 2, each of these has a weight factor. You're going to take the score, multiply it by the weight, and divide by the total score. That's weighted mean. And then if we keep going, we're on to measures of spread. So percentiles, population, it's the percentage of a population under a certain score. So 99th percentile baby is a big baby. And to get that, use this equation, and we'll do some examples in a second. And percentile rank is the data value of the percentile. So it's if I say, hey, I'm a 93rd percentile baby, how much do I weigh? We were kind of backwards. So to look at that, let's just look at some percentile questions here. On the bottom here, what percentile is this baby? 300 are there's 300 babies that are smaller than this baby. There are 20 that are the same weight as this baby, and there are 500 babies in total. What you're going to do is use this equation, find the percentile, and it's 100 times L plus 0.5 E times N. L is the number of values that are less than you. 20 are the number of values that are equal to you. So basically what happens is you say, I beat 300. I kind of tied 20. So I'm going to give myself a half value. So that's a 0.5 times 20. So that's going to be whatever that is, that's 10. And then you multiply by 100 and divide by 500 to find out that I'm in the 62nd percentile. So that's how you do that. If you have raw data, you got to put it in order. So this one here, I want to figure out a score in the 70th percentile. You put them all in order from first to last. And then a 7th percentile here. There's 21. If you look here, there's 21 pieces of data. So there's your N plus 1 over here. And then you use, if you want to figure out, a score that's in the 7th percentile. So different than the last question. What you're going to do is put 70 in here. Let me change the color of that to red. 70 goes here. Okay, so now the question is, what is a score that's in the 7th percentile? You put that into the equation, the other equation. So 70 goes here. That's N plus 1. Your answer is 15.4. 15.4 means that a 70th percentile score is somewhere between 15 and 16. So we don't get too specific here. All I do is go to the 15th value, which is that one, and the 16th value here, and then take the average of the two. So a 70th percentile puts me somewhere around here, and we'll just take the average of the two. Even if this was 15.1, we'll still take the average, or 15.9, we'll take the average. So it's not very specific, but it's not bad. Okay, so you go ahead and you do that, and that plus that divided by 2 is 54.5. If I want to go back and find out what is a score of 44 percentile is the kid in, what you do is, you look, you go over here. Let me go back up. You go up here and you say, look, I beat 1, 2, 3, 4, 5, 6, 7, 8, 9. Timmy beat 9 people. And then here, there are 2 guys here that are at 44. You might say to yourself, should the E be 1? No, E is 2. So it's not really the number of people you tied. It's the number of scores that are equal to that. That includes yourself. So if you are, if this is sample space, this is a sample, not population, and you're looking at that and you know that that's your score, you still include it in the E calculation. Okay, so 9 people scores are lower, 2 scores are equal. Throw that into the formula and you get 48th percentile. Okay, let's go and get a score in the 25th percentile. So when you do that, this is the same thing. We're looking at R equals, now we're looking at 25 over 100, N plus 1, 20 plus 1. You end up between the 5th and the 6th data point. That's 33 and 38. The average of 33 and 38 is 35.5. Okay, so let's just hold on to that for a second as we move on to deciles. Deciles are breaking, not percentiles. Percentiles are out of 100%, right? Latin for of 100, I don't know, something like that. Deciles, usually if you see deca, that sort of thing, that's Greek for 10. So deciles is breaking data into 10 parts. So this is the first decile, the second decile, the 10th decile, the 10th decile. So if you want to think to yourself, like, what about the 8th decile? Is that 10? Anyway, it doesn't matter. if that's 8th decile, that's like the 80th percentile, 90th percentile, somewhere around there. Okay. This isn't used much. It is in studies, but it's not used all that often. Percentiles definitely are. And then something else that's used all the time is quartiles. So what you do here is you break up data into 4 pieces. Okay, so you go Q1 breaks it into the bottom quartile. Q2 is so Q1 is the 25th percentile. That gives you my lowest quarter of data. The 50th percentile is called Q2 or the median. So that's right here. So now I go from the lowest 25 to 25 to 50, right? The kind of the first middle. The second middle is between 50 and 75. So that's from Q1 to Q2 and Q3. You'll see in a second. I'll make this look better. We don't use this shape. We use a different shape in a second. And that's the Q3 will get me there. What's the high score? We call that the max. What's the low score? We call it the min. The range is the max minus the min. So if I go back to this question here and I have everything in order, I say, what is my range? It's 61 subtract 22. Okay, so that's how you get the range for that. I think I do that somewhere here. Yeah, there we go. 61 subtract 22 is equal to 39. That's the range. Don't write this down. Don't write it like this. Kids like to sometimes write the range is between 22 and 61. That makes sense in a word answer, but not in a math answer. Math answer, I actually want the value of the difference between the two. So what we're going to have here is also the interquartile range, which I'll get to in a second. But what I want to do first is find Q1, Q2, Q3, and then we're going to make something called the box and whisker plot, which is a little different than anything we've seen, but it's kind of cool. So what you do is you find Q1. We already did that on the previous page, 25th percentile. The median is the middle one, 44. And then if I go through this and find the 75th percentile score, 75 divided by 100 times n plus 1, which is 21 plus 1, gets me the 16.5. I go back and find out the 16th score and the 17th score are actually the same. So therefore, I'm going to use Q3 as 55. Now, that was a lot. What I want to do now is with this data, make something called a box and whisker plot. So what you do is, I'll start from scratch here, okay? What you do is you start at the minimum, which is here. Then you go to the maximum, which is here. So you have 22. And then you have 61, and that's your min and your max. Then you give me Q1, which is 35.5, sorry. So that goes here, Q1. Q2, or the median, is here. If you were to do this properly, you might want to just be a little more careful on how this spaces out. Like this Q3 is going to be closer to the max than these guys are. We'll worry about that later. So your median's here. So Q2 or your median is here at 44. And this guy here, I guess, is Q3, a little bit further than what I have here, is Q3, which is 55. What we do to represent this data is we draw a box around from Q2 through Q2, that's Q1. From Q1 through Q2 all the way to Q3. So you put a box around the middle data, and then on the sides you have what we call the whiskers. Okay, so I got my first group of data here, the percentile, the second the 0 to 25 percentile, the first quartile, the second quartile, the third quartile, and then the fourth quartile. Here's the deal. This is where it gets confusing. So I probably said this in class, and this is very different than anything you've ever done. So when you look at things, usually the bigger something is, it means more things are in there, right? So every single graph you've ever done, bigger equals higher, right? Higher equals more. You got frequency or whatever it's going to be. In a circle graph, the bigger piece. So if this is a piece here, it's bigger. That means that there's more in it. This one's different. All of these quartiles have the same number of elements in there. So if we just pretend there's 100 kids that are writing a test, okay? So if we have 100 kids that are writing a test, or actually, let's not confuse ourselves. Let's make it even more, I want it different than percentiles, okay? Let's say I have 40 kids wrote that test, okay? I know we had 21, but let's pretend there's 40. That would mean that 10 kids have a score between here and here. 10 kids have a score between here and here. 10 kids have a score between here, and 10 kids have a score between here and here. So when you have something there's never a bigger amount. It's always the same, but what can happen is the size of these. So let me just change all this data, okay? So if I said right now that the lowest score was 33, and then, so over here, let's say it was 33 was my lowest score. What my box and whisker would look like, you know what, I'll just do it up here. The box and whisker would look like is if the lowest score was 33, this whisker, excuse me, to the mins, right, it would be 33, would be really short. So that doesn't mean there's less people in it. It means that the data itself is not spread out. Okay, it's very close to each other. So everything would be the lowest 10 kids are between 33 and 35.5. If let's say this guy, this Q3 wasn't 55, but let's say it was 60. Okay. Well, what would that do to my drawing? Okay, let's just think about this for a second. If this was 60, what would happen is this guy would be over here somewhere, right? Q3 would be over here somewhere. And this box would be like that. So Q3 would be a lot more spread out than what I see here. Okay, so the third quartile is more spread out, which would mean that not the first 10 kids are here, the second 10 kids are here. So the third group of 10 kids would be, their marks would be really spread out between 44 and 60. I think I said 60, right? So they'd be all over the place between 44 and 60. Okay. Then this group, the top group, would be all between 60 and 61. So these guys would be this whisker would be tiny, which means that the data is less spread out. Okay. So when you look at these sort of things, I do them like if we were to do this sort of thing here, right? If I was to make a box and whisker, I'm just making these up right now. And then this is the box, looks like this, and the whisker looks like that. That's kind of similar to what I said earlier, right? This quartile is really spread out. This quartile is really tight. This quartile is somewhat spread out, and this quartile is spread out. One problem you do have with this is if there were 10 kids in this quartile, I can't tell you if they're evenly spread out, okay, something like that, or if a bunch of them are here and only one guy's over here. I don't know that. Okay, I can't tell you if one's here, and then the rest are in the middle. Okay. We don't have that much detail. We break it up into quartiles. So when you do quartiles, you don't want to have to do it for something that's super specific. Okay, so that's that. That's how that works. If we were to draw this, class A and class B, class A has a 98. Oh, I forgot interquartile range, so I'll get to that in a second. 98 is this, the max. The low was 50. So here's 50 here. Okay, so that's 50. That's 99 or 98. Sorry. 55 is Q, so I'm going to do this. Q1, sorry, I keep doing that. Min Q1, median 66, which is somewhere around here. Median is here. And then 78, which is not too close, is over here. 78 is over here, which is Q3. If I was to draw this, it would look like this. You put the ends there. Then you draw the box around here. Okay, so note what's the tightest quartile. So here, if I had, let's say I had 40 kids in a class, it's a big class. This guy's really small, that guy's really small, these guys are spread out. What's that mean? This is really spread out. Okay, so this data is spread out. I still have 10 kids, 10 kids, 10 kids. If I was to look at the other class, my lowest mark is 42, so I'm down here somewhere. Okay, the range is 55. I did this again, I forgot interquartile range. Interquartile range is how big the box is. So you ask yourself, how big is the box? It's 78 subtract 55, which in this case is 23. So the IQR, or the interquartile range, is Q3 subtract Q1. Okay, so that's why you want to know that is you want to know how spread out the middle is. Because a lot of times when you're looking at data, the middle you kind of work together and say, okay, those guys in the middle. So if I was looking at a class, right, this is my middle kids in the class. They're the kind of like the core of the class. These kids are doing really well. I just kind of leave them alone. And then these guys are the guys I want to bump up a little bit. Okay. So when we look at the middle, instead of range, which is from here to here, subtract that, interquartile range is between here and here, which is the size of the box. So let's go back to class B. Class B has a low of 42. It has a interquartile, it has a range of 55. So that would mean that 55 and 42 would get me to 97. My max score would be 97, which is almost 98, but a little lower. Q1 is 50. So that's here. Making a mess of this. Q1 is 50. Q2 is 70, which is over here. So Q2 is here. And then Q3 is 87, which is over here. So the question is, how do these classes differ? How do I know which class is better than the other? All right. Notice the size of this guy, the box in this one, right? Way bigger, way bigger. Okay. So one thing you could say here is, that looks terrible. One thing that you could say here is that this there are people failing this class, right? I have 10 kids failing this class, which is not good. Okay. But I do have 10 kids over 87. That's good. Okay. The fact that the data in the middle is really spread out doesn't really say it's a good class or a bad class. I don't know. It's less consistent. Maybe that's a bad thing. Okay. This class is more consistent because the boxes are a little more, each piece is similar in size. Okay. I have no one failing. But then my highest level kids are a little bit lower. My average is higher, my middle score is higher here in class B. Okay, so that's kind of it. I'm running out of time, but that's how you make these. Take care. Bye.